Hello, I'm Harry Glorikian, and this is the Harry Glorikian Show, where we explore how technology is changing everything we know about healthcare. Is it possible that our tears are a signal of more than just our emotions? The answer is yes. It turns out that the liquid in tears comes from blood plasma and contains a lot of the same proteins and other biomolecules that circulate in the bloodstream. But they don't have a lot of the extra components, like antibodies, that would get in the way if you were looking for specific biomarkers, such as the low molecular weight proteins released as a byproduct of the inflammation around tumors. My guests today, Namida Daily and Omid Moghadam, are from a startup called Namida Lab. That's the first company to market a lab test using tears to predict cancer risk. Specifically, Namida's test assesses the short-term risk that a patient might have breast cancer as a way of helping them decide how soon to go in for a mammogram. Namida is actually the Japanese word for tears. And beyond breast cancer, the company aims to build a whole business around risk assessment and diagnostics using the biomarkers in tears. Eventually, it could be possible to collect a sample of your tears on a small strip of absorbent paper, send it into Namida Lab, and find out whether you have colon cancer, pancreatic cancer, prostate cancer, or ovarian cancer. The breast cancer test and the pan-cancer test that Namida is developing might sound familiar if you remember our January 2023 episode about GRAIL and their blood-based test, which can screen for 50 different cancers in a single blood draw. One big difference is that tears are way easier to obtain than blood. Another is that Namida's current test is much cheaper than GRAIL's. Namida's big vision is to use tear testing to make precision medicine and diagnostics more accessible and affordable, including to patients who might live far away from tertiary care centers. Omid and Anna and I talked through that vision back in February. Here's our full conversation. Omid, Ann, welcome to the show. Great to have you guys here.
Thank you, Harry. Appreciate the invite, and let me say that once you're being interviewed by the great Harry Glorikian on Moneyball Medicine, you've really made it. It's like playing the main room in Caesar's Palace.
I gotta figure out how to edit that out. But
What?
Thank you, Omid.
I'm bringing my A material to your podcast, Harry. What are you talking about?
So your company, I want to dig into, what you guys are doing and, what the company's working on. And, I tried to do all my homework but let's just start from the basic message. The company Namida Labs is working on, gauging breast cancer risk to decide how soon to have a mammogram simply by sending tears to your lab, right? And to a lot of people, I think the idea that tears might contain cancer biomarkers is probably new and surprising. So I want to step back a little bit and talk about, maybe you can start telling us a little bit about tears or how they're produced, what's the connection between tears and breast cancer, or maybe tears and useful biomarkers, and we can start there.
Sure. So Namida Lab, even though our first product is in breast cancer, we're a diagnostic company developing early cancer screening tests for various cancers using biomarkers found in tears. And I let our Chief Scientific Officer, Namida Daily, to tell you more about what's in tears, what is the relationship between tears and blood, and how these markers end up in tears and what we can see in there.
Great. Well, so tears have actually been studied as a diagnostic fluid for decades. We are just the first group to actually make a lab-developed test using tear fluid. The interesting thing about tears is we call tears and blood two sides of the same picture. So we know with blood, it's a very well characterized fluid. It's been studied for a long time, but it does have a lot of extra components in it. So it has lots of, you've got red blood cells, white blood cells, antibodies, large proteins. There's a big, the term that we use is dynamic range. So you have a lot of really big proteins down to really small proteins. When you're studying cancer biomarkers, so oncology markers are often in the low end of the dynamic range. They're often very small, low molecular weight markers. And it can take quite a bit of processing in a lab using blood to get down to that's low molecular weight. You have to do a lot of cleaning of the fluid. With tears, we can get to those low molecular weight biomarkers in one step. It's just a really easy, clean fluid because we don't have a lot of the large molecular weight proteins and cells and things in the way. And the way that we collect tear fluid is we use a piece of filter paper. It's called a Schirmer strip. It's what they used to use to detect dry eye. And so we place it inside the lower eyelid. We have the patient or customer close their eye, and the action of having something in your eye will cause your eye to water. But really what we're looking at is the proteins that we're interested in back and forth across those capillaries on the inner surface of the eye. And because of the characteristics of the protein, they will stick to that filter paper. So we take that filter paper out, we place it in a buffer that is shipped back to our lab. And in the process of shipment, the proteins will release off the paper and go back into the buffer. And the buffer itself is what we test in the lab. So it's just a really quick, lends itself very nicely to at-home collection. It's easy to do, easier than even putting in a contact lens. And it's a clean fluid that we can get to those low molecular weight proteins very easily. And the reason that we would see proteins in tears as related to breast cancer is simply because we're looking at inflammatory markers that are present in the breast tissue, and they're circulating throughout the body. And so that is just the place that we are picking them up, is inside the liver island.
Because it was funny, because I was thinking, like, how are you gonna collect the tears? I was thinking, like, do I have to watch a movie that like gets me all welled up and like they start streaming? Is the first thing I thought of. Because my wife will be like, whenever there's a sappy movie, you're always like welling up in some way, and I'm like, I can't help it. Like, so, but you guys, so the company describes the ARIA test, which is the test we're talking about, right, as a companion test that assesses breast cancer risk rather than actually diagnosing cancer. Let's just ask if that's correct or not.
Yes, that is correct. So
Okay.
the markers that we look at, because they're a part of the inflammatory process, can also be elevated due to a benign mass. So at this point, we don't differentiate between a benign inflammation due to a benign mass or a malignant tumor.
So we're going to get into some of those details later, but you don't see ARIA as a substitute for other types of testing like mammograms.
It's not designed at this time to be a substitute for mammography.
Okay. So at this point, so I want to step back in time, right? So, and you developed the test itself. How did you get interested in tears containing biomarkers, and how did the idea evolve into a company? And then, Omid, how did you wake up one morning and go like, yep, CEO, I'm going to do that job, sort of thing? So can you guys start? Anna, you start, and then
Okay.
Omid, you take over.
Okay.
Sure. So the early work around tears and breast cancer in Arkansas was done in academics, as it typically is with companies. And so there was some very preliminary research done at UAMS, which is our local medical school here in Arkansas, by a well-renowned breast surgical oncologist, Suzanne Klimberg. And so if we think of when we're looking at proteins, so what she did in her work was she basically found the map and not the name of the roads. It's kind of how I talk about it. So she figured out sort of the map and the direction, and my job was to come in and figure out what the exact roads were and really identify the route. And so the original idea and early work was hers, and then there was an incubating company that sort of came up with built the company around that idea, and that's when Omid and I
that's where we met. there was an academic incubator company here that was looking to start some new companies in the life sciences space, and I was leading that effort for them. And this was one of the technologies in the portfolio that we were looking at. And Anna was one of our scientists in the incubator that was. And the way it worked was that we would bring technologies in from universities and then do a proof of concept to make sure that we can validate what they had done in academic research, which is most times you cannot. So we learned that fairly quickly, that a lot of the IP coming out of universities was not replicable in real life. But this one we could. And so we worked on it part-time for a few years. Recruited a cohort of patients to do studies, and once we figured out what these markers actually were, then we launched a company to commercialize it. And that company was founded in 2013, and it went on for 6 years until it was acquired to create Namida. And at the time, we were working on an FDA-cleared device, a cartridge, a paper-based cartridge for diagnostic. But we ran into the Theranos debacle, and finding funding for anything in diagnostic at that time was almost impossible. And so that's why the work took longer, because we just had to do it with limited resources. But we managed to do it, went through an acquisition, Namida was founded, and the strategy of the company changed to not just a cartridge and FDA cleared, but go for anything. So if it makes to be an LDT, let's go and do an LDT. If we want to go for a breakthrough device, say if it's an ovarian cancer, we'll go for breakthrough device designation. So we just expanded sort of like regulatory pathways. And the first one happened to be in breast cancer. And post-COVID, the whole idea of direct-to-consumer testing or consumer-directed testing became more prevalent and well-funded. And that's why we released ARIA as a direct-to-consumer test into that market, using our own developed digital platform.
So let's talk a little bit more about the science using tears for cancer screening and some of the other questions that motivated, you guys to start down this path, right? So there's a growing recognition that, we can screen fluids like blood for cancer biomarkers. In fact, I recently had the president of GRAIL on the show talking about their work, right, to develop a test that can screen a blood sample for, say, 50 different cancers by looking at free-floating DNA shed by tumors. But I think your argument is that blood may not actually be the best, as you mentioned earlier, to test for cancer. And tears might actually be better in some cases. So I'd like to unpack that a little more, right? So are there components in blood that are not found in tears that can get in the way of finding these cancer biomarkers? Are there practical and economical advantages to testing tears rather than blood, right? Because I can imagine that someone arguing that it's easier to get a tear sample, like you said, than trying to find a phlebotomist to stick a needle in my arm. You mentioned that the tears are easier and faster to process than the blood. So walk me through some of that for the listeners.
Sure. So, there's a lot to unpack there, but when we think about ease of getting to a protein, and here we're looking at protein. So GRAIL looks at DNA, and they're looking at DNA shed from tumor cells that are circulating throughout the body. Mm-hmm. So there's a lot of different things we can think about when we think of cost of testing. GRAIL's test is quite a bit more expensive. Of course, they're looking at a lot of different cancers, but their test is quite a bit more expensive. So we wanted something that could be easily attainable, could be done in any clinic or any home by our users. And so, and keeping the cost low. And that's something that tear fluid really lends itself nicely to. And then we're looking at protein instead of DNA. So looking at protein, we're doing a sandwich-based ELISA in the lab. That's a fairly cheap, well-established, easy process to do. We can get to, as I mentioned, we can get to those low molecular weight biomarkers easily in tears without having a lot of cleanup to be done. And so, and our interest in doing when we talk about proteins, we're talking about a short-term, real-time risk. So if you're looking at genetic testing to determine your that looks at if you're not looking at tumor shedding, you're looking at, like the BRCA testing and those kind of things. So that's looking at the propensity, the possibility that you may at some point in your life develop cancer. So that's a long-term risk. Our test is a short-term, real-time risk. We're looking at what's going on in your tissue right now that could help you make a decision for your next step of care. And so, there are uses for both testing platforms, and we're not saying that tears are a better source for diagnostics and screening, but it is an equally accessible and very nice source for the type of testing that we're doing. And I think when we look into kind of where diagnostic testing is going and getting that into our, getting that out to people and easy to use, tears are just a beautiful way to do that. And so, there are some components that can get in the way with blood. I think, they complement each other very nicely. We've done some studies to look at just to see if we can see things in tears that you can't see in blood. It's just easier to get to. They're there. It's just easier to get to in tears when we're looking at proteomics. And we've done some mRNA studies as well with tears, so you can see genetic components in tears as well. But for what we're doing and how we're targeting our testing to be, screening, population-based testing, then tears are just a really nice fluid and much lower cost than doing, say, a Grail type test.
Okay.
If I missed anything.
No. It's the tears are highly concentrated, so those low abundant proteins are easier to find. So it's the economics of it works really well. You can still make a profitable test at a low cost.
So now that we've jumped into the protein markers you're talking about, right? So you guys published, or Anna, you published a paper in PLOS1 in 2022. And in the paper, you actually named, I guess, the three main biomarkers you're looking at: S100A8, S100A9, and then which are generally, if I read it correctly, elevated in breast cancer patients, and galectin-3 binding protein, which is found at lower levels in breast cancer patients. What's the relationship between these three proteins to breast cancer? Are they markers of inflammation or some other abnormality in breast tissue? Are these the same proteins you're looking for in the test, or are there others?
Yeah, so the two A8 and A9, those are the proteins that we use in our ARIA calculation to calculate your score. They are part of the inflammatory process. They're part of the early process that sort of gets that tissue ready for tumor formation. So recruiting a lot of the immune system to that spot. A9 is part of the cascade that is activated by BRCA2. So it does have, and both of those have been extensively studied in tissue in breast cancer as well. So there's a long sort of academic history of A8 and A9 being studied in breast cancer specifically. And we were just fortunate that we can see them in tears as well quite easily.
So let's talk about the readout from the test, right? So I understand that women get back what is basically a very simple chart that says low, medium, high level risk for breast cancer. What goes into the assessment? I mean, how do you weigh the combined assay results and sort women into one of those three buckets? What does medium mean? What does high mean? What do you recommend that women do with this information, right? I was sort of looking at the FAQ on the site, that the test is intended for women with average to low risk of breast cancer. Can you explain that? So I'm just, if you can walk me through what goes into the assessment, what the different buckets might mean to someone who's looking at them?
Sure. Yes. So when you activate your kit, our customer will fill out a short health survey as well as a breast health survey. And then when we determine your protein concentrations in the lab, we have an algorithm that we use that takes those two protein concentrations together with some clinical information to calculate their score. And then that score is what we compare to the scale to put them into the low, medium, or high category. So those categories were built using the over 2,000 samples that we had studied over 10 years of time, and then going back and looking to see how soon. So if we set someone, if our test said someone was medium or high, but mammography said they may be normal, how soon did they come back with a finding based on our test? So looking out, we went up to 5 years, I think, to see how soon someone had come back in. And so that's how we developed the low, medium, and high. And with those low, medium, and high are recommended time points on how soon you might want to consider going in for your mammography or your follow-up imaging, depending on your age, your breast tissue, and your risk level. So when we first started, we really, because we were utilizing this test to be a patient activation tool to get women in for screening mammography, we said low to average risk, because normally if you're high risk for breast cancer, you're already on a pretty stringent regime of imaging. Normally that's a screening mammogram and 6 months later an MRI, and you alternate those every 6 months. And so we didn't want to get in the way of what women were already doing. We've kind of lessened that sort of jargon, because what we're really wanting to do is not only provide women with information about what's going on in their body, but part of the test is a breast health consultation. So we have RNs and APNs who've spent their career navigating women from everything from a screening mammogram to all the way through breast cancer care. And so, when we look at the statistics, what we see is that across the board, about 50% of women will go in for their screening mammogram. When you get down to the lower age range, so around 45, 50, you're looking at about 37% of women go in. And that doesn't matter if you're low risk, medium, or high risk. That doesn't, or if you've been told you're high risk, a lot of women will still not do the recommended imaging because it's time intensive. And so what we're wanting to do is provide a conversation that often breast centers and OBGYNs just don't have time to have in an extended setting. So we say 15 minutes, our breast health specialist will spend as long a time with you as you want and discuss your history, your family history, your concerns, maybe a past imaging issue. And we found that to be very successful to get women who were screening averse, who had no intention of going in for a mammogram, but came back medium or high on our test, and then had the conversation with the breast health specialist, and then went ahead and went in. And we have had women have findings based on that pathway. And so really what we're wanting to do is sort of assist that screening conversation education process with this at-home test and our breast health consultation process.
Yeah, that was going to be one of my next questions is, what is the gap you guys are filling and what behaviors are you trying to change? And so I've always believed, like, when you have data and you show patients, right, that they will probably, not all the time, but probably change their behavior or, take that next step because there's a piece of data that says something might be going in the wrong direction.
Right.
But from what I'm understanding is you're trying to fill that gap of, hey, once a year might not be enough. You can do this test that might indicate that you need to have that mammogram, within a shorter period of time than you might normally think.
Right, or do one at all, because a lot of women do not do that. We recently had a small scale pilot with an employer, with a self-insured employer, with the women in their headquarters, and it was about 100 women, and we found 3 breast anomalies, and these were women who were not planning on going for mammogram, had no intention of going, or if they had gone, they were already cleared. So it was a success, and as a result, the company now wants to do a larger one of 1,000 women.
Yeah, that was going to be one of my next questions, or like, the clinical evidence to drive somebody to have it in a shorter period of time, but also maybe wait longer than 12 months, right? So, how do you guys think about this? And the public health aspect, the economic aspect, or, I almost think like what you guys are saying is we need to come up with a better job of stratifying access to cancer screening by risk levels.
Yes, risk-based screening is definitely interesting. In Arkansas, we're a pretty rural state, so we have about 23 counties where women have to drive at least an hour or more to get to a screening facility. So these are a lot of places where, they're just not going to be able to take the time to do that. And so if we can get something to them in their home, then that gives them a means of doing something to monitor their health. And, we know there's a lot of insurance companies and different payers that are starting to spread out how often you have a screening mammogram. So maybe they'll only cover every other year up to a certain age. We're starting to see that more and more. And so, the other thing is, as a country, we do way more screenings than most other countries do. And our quality of life and our longevity is lower than a lot of other places. So we're obviously not hitting the need that needs to be hit. So, here we're just trying to, can we really get the people in who need to be in? And if you can take a little bit more time, let's see if we can help make that possible.
So obviously my background being diagnostics, right? Well, I'd love to talk a little bit about sensitivity, specificity, right? Same sort of thing I did with Grail, but on the website, right, it says that the test will detect 92% of people with a breast abnormality, which translates into a 8% false positive. But the site also says that it will identify 54% of people who don't have an abnormality, which translates to, I think it's 46% false negative. I don't know, that seems a little high, but I'm maybe not. I mean, how do you like to talk about specificity, sensitivity, especially when you compare ARIA to tests like mammography?
Right. So a mammogram, given it depends on what type of breast tissue you have and what type of screening modality you're using, can be anywhere from 60 to 75% sensitive. A specificity can be anywhere from 75 to 90, just depending on, again, breast tissue. It's lower if you have very high tissue density. We have set the cutoffs, our cutoffs on our scale have been set to have a higher sensitivity, so we have a lower false negative rate. And if you're familiar with sensitivity and specificity, it's a balancing game. So right now our baseline is 92% sensitive, which kind of drops the specificity down around 54%, which means we have a higher false positive rate. And when we're talking about a cancer screening diagnostic, you want to have as high sensitivity as you can get. Now we have a lot of work and some papers that are coming out that will feel like we're going to be able to raise that specificity up, which is going to help. But that's because of the high false positive rates. That's why we position this test to be prior to screening mammography as a pre-screen. We're not saying don't do a mammogram. We're saying do our test, get some information about yourself, be informed and educated when you go in for your screening, and get some extra questions that you can ask. So that it's really, we are continuing to improve that. But we're happy with this as a starting point, and we've seen this test to do exactly what we have positioned it to do.
Yeah, you always have to worry about like, what do people do with the information, and then how do you make sure that they're educated to like even if they showed up low, not skip the mammogram that they need to take, right? When it's the appropriate.
That consultation, that's part of our product offering. Yep. is exactly for that. So our customers are educated about the results of the test. They understand their family history and what they need to do for their breast health.
So now let's jump to the economics, right? Because how much does a test cost for the average person? Do any insurers cover it? I assume you're working on getting it covered. And is the test available by prescription only? So I'm trying to just understand where in all of that complexity things are with the test.
It's a lab developed test. So yes, it requires a prescription, which is done through our 50 state coverage. We have physicians with 50 state coverage. And so that is the prescription is generated when you buy the test. The test is $159. It's at aria.care. And that includes everything: the prescription, the test, back and forth shipping, and results, and the consultation at the end.
So are you guys working on a over-the-counter version? I'm just wondering.
Not at the moment. Well, what we're working on is increasing the specificity and then a diagnostic version of the test.
So if I'm also not mistaken, you guys have another test that's called Melody. What's the difference between Melody and Aria?
Yeah, so Melody is a sort of the clinical application of the algorithm. So instead of having the kit and the scale and the consultation, Melody would be, if we have a physician that's interested in offering this to their patients, then they can make the interpretation themselves and decide, how they want to move forward. So really, we see this more in like an ACO setting, and that sort of thing is really where Melody is.
Yeah. So Aria puts the customer in one of the three buckets: high, medium, and low. Melody has a cutoff point, so it's like Cologuard: clinically relevant, clinically not relevant. Clinically significant versus clinically not significant. So Melody has that cutoff point, which, as Anna said, it's more for a clinical setting, and we're going after the ACO market for that.
Okay, so I know we're talking about, we talked about blood and tears. Makes me beg ask the question about, I don't know, what about sweat or urine? I'm trying to figure out why tears, I guess, based on all the work that you guys have done.
Sure. Where there's, there is work in other fluids. Urine is a concentration issue. And when you get, obviously, it's a higher volume, so it's a lot more work in the lab process to get down to the low molecular weight proteins. Saliva is a cleanliness issue again. It can take quite a bit to collect those samples, and it's just a processing work. And tears are it's just a easy way for patients to collect their sample, and we can get to those proteins quickly. Sweat, I'm not sure about that one. I know that there are some work in exocrine glands, and then there is a breath test as well to look at. That one is esophageal, stomach cancer.
Stomach cancers.
But yes, there's lots of work being done in other diagnostic fluids. I think we're starting to see there's lots of different ways to figure out what's going on in the body, and tears are just another really nice way to do that.
So I know you guys are working in breast, right? So the product is now sort of lightning focused on women, but I believe the website also says that you're working on tests for pancreatic, melanoma, ovarian, colon, and prostate, right? So can you talk a little bit about your pan-cancer study? What are the additional challenges of screening for these other types of cancers?
Well, I will say, when you're working in tears, the biggest challenge, no matter what type of cancer you're looking at, is getting samples. Because much like, with blood, there's often biobanks. You can just purchase samples of anything you're interested in. Anytime we come up with a new question we want to study, we have to collect a new batch of samples. And so that's really the biggest issue. If we can find a clinic that is excited and wants to collect samples and wants to be part of it, that's often that's once that hurdle's overcome, we can get the samples. And we've been really lucky to find some very nice clinical partners that have been excited about the pan cancer study. So we have a nice data set, early data set in prostate, ovarian. And so ovarian is the hardest to get. It's just a challenging diagnosis. And so just finding the right clinical point to get those samples. And then, so we have some early work in prostate. We have a sample bank for colon, pancreatic, and a few in melanoma. And so really it's just kind of moving that discovery work forward. But that's sort of where the trajectory is going. But really the biggest issue is finding clinical partners. Once we get those samples in, from there, it's pretty straightforward on how we do it.
So I'm going to assume, like, once you get the samples and you're doing your analysis, this is where I'm making a grand assumption that there's some artificial intelligence, machine learning approach, right, to decipher all these signals to understand, how to bucket these and therefore apply them to a specific cancer that you're going to call in the end based on the results of the test.
Yes. So I'll let you talk about.
Well, we start with, I think the early look at the data is typical normal statistical analysis, because what we're looking for is the difference between cancerous and non-cancerous spectrum of proteins. But once you get all of the data, all of the patient data, which means their history, all the information from the EMR data that we get in, and we marry that to maybe if they have any genetic testing, that big data set is where machine learning comes in, because it's not just the levels of proteins, but it also that proprietary algorithm that has some demographic and some historical data in it that would give us that final sort of like cutoff point in where we make the clinically significant versus clinically not significant cutoff. And that's where the machine learning work comes in. And as a matter of fact, there's this sort of like a history around how ARIA was developed that had something to do with that. As Anna said, in our early studies, we had some false positives of our work that were ruled out by mammograms, but then those patients came back with cancer a few months later. And that sort of prompted this, that maybe we should take a look at our bigger data set and do some machine learning work and use artificial intelligence to see perhaps something that we're missing here, because it seems that we have detected things early enough that mammographers have missed it the first time around, but a few months later they have found it. And that's sort of what eventually led to this idea that maybe we should make a test that gives you a risk, it's sort of like a 12-month risk. If you're in the high 3 to 6 months, 6 to 12 months, and 12 months plus categories of when you get your mammogram. And that came out of a collaboration with a machine learning company. And not only that, but then they gave us, we found some more targets where we can actually take our knowledge of tier proteomics with a proprietary algorithm into a diagnostic test. And that's our next, that is also in our R&D pipeline, to turn our test into a diagnostic test, which can actually say whether you have breast cancer or not with a tier test.
Yeah, it's not surprising. If you know the work, like, not far down the road, Regina Barzelay's lab at MIT, like, she can see something 5 years before the human will actually be able to point at it, right? So the machines can do a much better job of identifying either images or, we can detect stuff at such a low level now. I think that we can get ahead of the actual tumor formation, which is where, you got to use your eye and be able to see it. So I think we're on the cusp of changing medical practice. I'm not sure that the medical schools and everything are going to be able to keep up, but I think we're at that stage now with all these technologies that we can throw at this. But what's the long-term plan for Namida? I'm assuming, is it to become a general cancer screening company with tiers as the special sauce?
Yes. Yeah, we would like to have a pan-cancer test using tears as the medium of testing. You know, highly concentrated, sterile fluid that's easy to collect by the consumer and inexpensive. I think those are all the points that we'd like to hit. And you know, we've proven that there's a there with our proof of concept, this breast cancer test. And we would like to extend that R&D into diagnostic tests and also other screening tests.
Well, I think I've gone through all of my questions on this end. I don't think I missed anything, did I?
No, it's all good, Harry.
So it was great to have you guys on the show. I mean, I only wish you like huge success and hope this goes forward, because you know we need more good diagnostic products out on the market that can help people stratify themselves and understand when to get tested. So, you know, it was great to have you guys on the show today.
Appreciate it, Harry. Thank you for the invitation.